This video is on synthetic division. We're going to start, actually. Synthetic division is a dividing technique for polynomials, dividing by polynomials in the special circumstances that you are dividing by a linear divisor with a slope of 1. We'll talk more about that in just a second. But I want to begin by refreshing our memory about a high school topic, polynomial long division. So we're going to perform the polynomial long division. X cubed minus 5x squared plus 4x plus 8 divided by x minus 3. Now this is our divisor. It is linear because it's of degree 1. And it has a slope of 1. So this does meet the qualifications for our shortcut. So we will be applying the shortcut to this same problem, but first we're going to do it the long way. So in order to do polynomial long division, I'm going to ignore everything except for the leading terms. And I'm going to divide x cubed by x. Another way to think about that is what would I need to multiply x by to get x cubed? And the answer is x squared. So my next step is to multiply x squared times x minus 3. So I'll need to distribute that, and I'm going to write my result underneath this polynomial, lining up like terms. So x squared times x is x cubed. X squared times negative 3 is negative 3x squared. Now I'm going to subtract. So you may also want to notice how similar this is to arithmetic long division, where we multiply and subtract. I do want to distribute this negative, so that's where it differs from arithmetic long division. When I distribute this negative, everything in here is going to change sign. I did that in a different color because I do want to emphasize that we are subtracting and distributing. That distributing is a separate step. Now I'm going to actually combine my like terms here. So the x cubed minus the x cubed, well, that'll go away. Negative 5x squared plus 3x squared is negative 2x squared. And then I'm going to bring down my next term. So now we do the whole thing over again. I want to figure out what do I need to multiply x by in order to get negative 2x squared. And the answer to that is negative 2x. So negative 2x times x is negative 2x squared. Negative 2x times negative 3 is positive 6x. I'm going to subtract that entire thing. I'm going to distribute the negative again, and again I'm writing it in a separate color. Of course, you don't have to write it in a separate color, but you do have to be aware that it is a separate step. When I actually do my subtraction, that will cancel out, and I'll have 4x minus 6x, which is negative 2x, and then I bring down my next term. So again, I want to, what do I need to multiply x by to get negative 2x? And of course that's negative 2. Negative 2 times x will be negative 2x. Negative 2 times negative 3 is positive 6. I'm going to subtract the entire thing. I'm going to distribute my negative. This will cancel out, and 8 minus 6 is 2. So I don't have anything else to bring down. you can say that you've got a quotient of x squared minus 2x minus 2 with a remainder of 2, or you can say x cubed minus 5x squared plus 4x plus 8 divided by x minus 3, because that's what we had been doing. Well, that is equal to x squared minus 2x minus 2 plus 2 over the divisor, which is x minus 3. You do need to be aware that that 2 is called a remainder. And you need to be able to answer in both ways, that it's you have a quotient of x squared minus 2x minus 2 with a remainder of 2, or I can write it like this, x squared minus 2x minus 2 plus 2 over x minus 3. Now that's polynomial long division. That is all technically a prerequisite for this course. Now to the side here, I'm going to introduce our synthetic division, which some people may have seen before, but is not part of the prerequisite of this course. Really, what makes the synthetic division so much faster is that you're just not writing everything down. There was a lot of repetition in what we wrote down. We're going to ignore everything except for the coefficients. Notice that this doesn't have an explicit coefficient written, and so that is a coefficient of 1. So my coefficients of my dividend, this thing under the division sign, the polynomial that I'm dividing into, those coefficients are 1, negative 5, 4, and 8. And now notice how each time I subtracted and then distributed the negative, what we're going to do is sort of pre-distribute our negative, and we're going to take the opposite of this minus 3. So this was x minus 3, so I'm going to write a positive 3 right there. So now my synthetic division, I'm not going to write down very much, but that's what makes it a shortcut. The first thing I do is just bring down the first coefficient here, this first number, drop it down, and then I multiply 3 times 1. So 3 times 1 is 3, and I'm going to write that result right here. Next, I'm going to add these two numbers. We were subtracting before all the time, but remember we sort of pre-distributed the negative, and that's going to allow us to add over and over again, which is also a faster operation. So negative 5 plus 3 is negative 2. Then I'm going to multiply again. 3 times negative 2 is negative 6. Then 4 plus negative 6 is negative 2. 3 times negative 2, well, that's negative 6 again. And 8 plus negative 6 is positive 2. So now I want to point out the similarities here. Change color. This is the remainder. Your last number that you write down is always going to be your remainder. Then this is the constant term. This is your x term. And this is your x squared term. If we had a longer list of numbers, we could still start from the right-hand side. We'd have a remainder, then a constant term, then an x term, then an x squared term. If we had lots of numbers, we'd have an x cubed, maybe an x to the 4th. However far you need to count going left. Now, notice that these numbers are the same as our coefficients of our result. So that was our remainder. And we've got x squared minus 2x minus 2 with, and we can always put our remainder over our divisor. Now your divisor will always be x minus this number. And so there is our result. We got the same thing with our shortcut as we did doing it the long way. Let's do another example. Let's see. So I have this problem here where I want to divide. Now notice that I don't have a term for my x written out. We'll handle that in a second. First, I want to mention that this only works if your divisor is linear. That is, it just has an x without a x squared, x to the third, anything like that. It has to be divided by something of degree 1 with a slope of 1. So this does meet our qualifications to perform synthetic division. First, I want to rewrite this so that I have something, so I have a term written explicitly for every degree less than the degree of the polynomial. And the way that I'm going to force an x term to show up is by writing x squared plus 0x plus 5. This is important because when I'm doing the synthetic, it's all about position. I'm not writing down x's. And so I need to keep track of what my terms are by their position. And I've got x plus 1. Remember, we always take the opposite of this number. So that's going to be a negative 1. So now I'm ready to perform my synthetic division. I bring down the 1 first, then I multiply, so that'll give me a negative 1. Then I add, so that'll be a negative 1. And then negative 1 times negative 1 is positive 1. I add, and I get a 6. So now I need to interpret this answer. Remember, this term is always my remainder. This is my constant term. This is my x term. And that's all I've got from this result. So my result is going to be x minus 1. And I can write that as a 6 over the divisor, and remember the divisor was x plus 1. If someone asks you whether something is evenly divisible, remember to be evenly divisible means that it has a remainder of 0. That's what it means when you're doing division with numbers, and that's exactly what it means when you're doing division with polynomials. So this is not evenly divisible because it has a remainder of 6. If it were evenly divisible by, if x squared plus 5 were evenly divisible by x plus 1, this remainder would have been 0. It's not, and so I know that this is not evenly divisible. There will be many more examples of synthetic division when you watch the Finding Zeros of Polynomial Functions example. Sorry for bumping the camera there.